A little hint here for your Pendulum Lab. Synthesis, page 199, page 201, part G. You're given length of the pendulum is 100 centimeters, 1.0 meters, and the amplitude as 0.5 meters, or 50 centimeters it says, but of course put them into your SI base units. So remember there was length and amplitude, but of course for a pendulum, from its rest position, well, a pendulum normally, where it's attached, of course, down to the very lowest position. In this case, it's 1.0 meters. That's the length of your pendulum. But think about how your pendulum worked as you went back and forth. Take a look at the actual height of the end of your pendulum. The bob actually rises up. So it arcs up, and if you notice, it is now, if I draw this in, there's where your pendulum bob is. It's now higher up from where it was. So we are given, of course, the length of the pendulum, 1.0 meters. But that bob was actually down lower because that length of the pendulum string was from where it was attached down to the very bottom or lowest point. So if you were to draw some horizontal and vertical lines here, so of course your vertical comes right across from the pendulum bob now to where it hit before. This is where it was before. It was down here at its lowest position. So remember, you're given amplitude. That's how far it comes back from rest position to the farthest point away. And that was given as 0.5 meters up here. So if you have this as set at 0.5, again, from that rest position out to where the pendulum bob goes, take a look at some of these numbers. And this number here, and also notice that this, of course, between your vertical and horizontal, that's a 90 degree there. And right here is something you can calculate if you're pretty good at your geometry. And then you can take a look at, of course, the difference in height. And the other big hint there in part G is to apply the law of conservation of mechanical energy in this problem. So you're taking a look at mechanical energy. Remember mechanical energy at the top and what it is at the bottom, and the difference between your gravitational potential and kinetic. And of course, I think you've got enough to solve it.